Hello, we are the explorators of Group 7 from N Division presenting our first year engineering project which was as a part of Engineering Exploration course project. We have named our project as Deco Robo and it belongs to the need statement Decoratives. Our team members are I am Abhinav Shetty, Sona Shetty, Kripa Patil, Rajat Revankar. We have been working under the guidance of Professor Kaushik Malibhat. We have followed 5 steps of engineering design process to complete this project. Let me explain one by one. So, this is the first step, which is the problem definition, which highlights objectives, constraints and functions. As you can see, objectives are in purple color, constraints are in red color and the functions are in black color. Further, the functions can be elaborated into sub-functions as shown in the function tree and clustered them. Here are the subsystems identified for our project. Sensor unit as an input, light emitting unit as an output, display unit as output, audio unit as output and movement unit as output.
Now, let me describe the second step of design process, which is conceptual design. For the following functions, in order to realize the functions, we were trying to generate different alternatives, where we were able to come up with 4 such diverse solutions. So, these are the generated concepts. After using brainstorming and puck chart technique, we were able to select one of the best design. The puck chart provides us the information which design was the most effective one. So we choose design 4 as a selected design. The selected concept for our project is concept number 4. These are the score given and justification given to various concepts. We will move on to the product architecture phase, which is the third phase of engineering design process. During this phase, the considered functions and identified subsystems are further analyzed with length of interaction among them. As you all know, the subsystems of a project are sensor unit, light emitting unit, display unit, audio unit and movement unit. The different types of interactions among these 4 subsystems are spatial interaction, data interaction and material interaction.
In the detailed design, we went ahead with the circuit diagram, flowchart, bill of materials. Let us describe each one of them.
As you can see, we have used the Autodesk Inventor Professional 2019 application to construct this 3D model.
Interactions are normally identified in terms of data, material, spatial. However, in our case, interactions are restricted only to data and spatial. Having identified each of the subsystems, we are now visualizing it by developing a 3D model. So, this is our 3D model. Our 3D model consists of 3 subparts. They are firstly the head, next comes the body, next comes the leg. In the head part, there are 3 subsystems involved in this. The first is the ultrasonic sensor, which senses the ones present. Then next comes the LED strip. LED strips are placed in the outer ring over here. These strips produce the light of different colors and patterns. Then here we have placed the speaker. This speaker is internally connected to SD card holder. Here these pipes help in connecting the head to the body. So next comes the body part. This is our body part. Here we have placed the display board. This display board will help to display a greeting. Here at the top of the body there are few holes which help to connect body and the head part. Similarly at the bottom there are another 2 holes which help in connecting the leg and the body part. Inner to the body, we have placed all the Arduino system which helps in interconnecting each of the subsystem. Then comes the leg part. Here in the leg part, this part will help in connecting the body to the leg. Inner to the leg, we have placed a DC motor. This DC motor helps in the movement of the leg. This shows the movement of entire body. So, this is our final assembly of the body.
Circuit diagram of the entire system. We have used circuit.io software to realize this circuit. The components used in this circuit are: this is an ultrasonic sensor which is used to sense one's presence. This is a speaker which is used to produce sounds. This is an SD card slot where SD card is placed, due to which the sound is generated to speakers. This is a LCD display 16:2 which is used to display. It displays numericals or alphabets. This is a potentiometer. These are the resistors. These are the two DC motors of 60 RPM. This is an LED strip of different lights. All the components are connected to breadboard and the wires through breadboard are connected to Arduino.
Bill of materials was also the part of our deliverable where we listed all the components required to build each of the subsystems as shown in the figure.
Speaking about the flowchart of the entire system, when the Decorobo is plugged in, the sensor detects for any obstacle. If there is an obstacle, then the LED blinks in pattern 1 and 2, produces pleasant music, followed by DC motors turning on, and both the legs rotate by 360 degrees. The process is repeated again. If the sensor does not detect any obstacle, then it displays greeting or team name on the LCD display board, and then it is stopped manually.
Now let's see the motor sizing and battery sizing of a project. First, let's see the battery sizing. The maximum current drawn from DC motor is 300 milliamps and the running time of DC motor is 3 hours and the number of motors used is 2. Now we can obtain the charge by multiplying the current drawn by motor into running time into number of motors used, where the charge obtained will be 300 into 3 into 2, which is equal to 1800 milliampere hour. Now let's move on to motor sizing. The torque of the DC motor is calculated by T equal to F into D by 2, where F is the force and D is the diameter of the DC motor. Again further, force F is obtained by multiplying M into G, where M is mass in kg and G is 9.81 meter per second square, where M is equal to 1 and G is 9.81, thus the force obtained is 9.81 Newton. And the diameter of DC motor is 25 mm, which is equal to 2.5 centimeter. By substituting the value of force F and diameter D in torque equation, we get the torque as 12.2625 Newton per centimeter, which is equal to 1.25 kg per centimeter. With reference to this rated torque, the speed of the motor should be 60 rpm, rotation per minute.
So, here are the function specifications of entire system. In our system, there are 5 functions. They are: first one is to sense one's presence. So, for sensing, we are using the ultrasonic sensor. It will sense a people in the range of 2 to 8 cm. Next system is to produce sound effect. So, it must produce a sound effect by the help of music player. This music player will range up to 4 to 8 ohm speaker. Next function is to emit light. It must emit light of different colors and patterns for 5 seconds. And patterns are of 2 different types. Next is to show intricate movements. It must be able to rotate its leg. Next comes the display greeting. It must display greeting or team name on the display board.
Now, speaking about the fifth step of engineering design process, which is design communication, we have used a platform called GitHub to document all the artifacts related to our project Decorobo. As you can see, we have uploaded the pages based on the instructions given by our guide. It is easier to view and make changes when necessary. Hello, I'm Sona. I'll be talking a few words about simulation and modeling of our project Decorobo. We have used a platform called Tinkercad to show the simulations of our project. Firstly, we have used three microcontrollers, that is, three Arduino Unos. We have grouped certain subunits and used an Arduino each. We have used an Arduino for the simulation of two DC motors, an Arduino for ultrasonic sensor and LED strip together, and lastly, an Arduino for display and music. Now, let us see the simulation of two DC motors. We have two DC motors, two BJT transistors, two diodes, and two resistors. As you can see, the yellow wire is connected from motor 1 to pin number 3, and the purple wire represents the connection of motor 2 with the pin number 4. The black wire always represents the connection of the motor with the ground pin of the Arduino, and the red wire represents the connection of the motor to the 5 volts of the Arduino. Now, let us see the code. As you can see, digital write motor pin 1 high and digital write motor pin 2 high states that the motor is going to rotate continuously without any stop, since it is present in the void loop section. Now, let us start the simulation. Now, let us look at the Arduino number 2, which is connected to the sensor, and the new pixel light strip, which is 6 in number. As you can see, the ground 5 volt and the signal is connected to the ground 5 volt and the 7th pin of the Arduino board respectively. In the NeoPixel light strip, the DIN, which is the data pin, the 5 volt and the ground is connected to 6th, 5 volts and the ground of the Arduino board respectively. You can see that there is a single RGB LED light also present to indicate at what distance the obstacle is present. Now, let me show you the simulation. First of all, the code is something like this. The color of the light changes from red, then to green, and then to blue in the NeoPixel light strip. But what about that single RGB LED light that's glowing blue in color? It's because I've set the conditions in such a way that when the obstacles is present within a range of 10 to 50 inches, then it has to glow in blue in color. But the same thing happens in green when the obstacle is present beyond 50 inches, and it glows red when the obstacle is very near to the sensor, that is inside 10 inches. You can see how it is interpreted in the video. Since the simulation takes time, the color changes slowly. You can see that the color has changed into red now. And then now into green, because the obstacle is beyond 50 inches. Now, let us take a look at the Arduino 3, which is connected to the LCD display board of 16x2 character strength and a piezo buzzer. There are two resistors attached as well and a potentiometer. Now, let us look at the code. You can see that there are various tones included over here, which results in the Star Wars theme. We have selected the Star Wars theme as the audio which will be played by the piezo buzzer. Now let us look at the simulation. Did you notice how Group 7 was displayed perfectly, but the audio could not be heard clearly? It was because we used many Arduinos. As we use many Arduinos, it becomes more compact and the simulation time becomes gradually slower. So, let me just show you how it would actually sound with just display and audio together with the same code. How was the Star Wars theme song? Good, isn't it? This is a glimpse of our physical implementation process. When we place our hands in front of the ultrasonic sensor, the LED glows. When we remove it, it doesn't. As you can see, this was a part of our physical implementation process. When we would place our hands in front of the sensor, the LED would glow. If not, it wouldn't. Last but not the least, we would like to thank our guide Sir Kaushik Malibat, the entire SEER team KLE Tech for providing us such a remarkable opportunity. It was a wonderful experience in building our project. We will look forward to have such wonderful experiences in our higher semesters too. Thank you.